Welcome to Walkabout the Galaxy, the whimsical astronomy podcast where the science is universal, the opinions are personal, and the sponsor is rhyming. We are Strange, Charm, and Top the Astroquarks, also known as Josh Caldwell, Addie Dove, and Jim Cooney, coming to you from 17 meters above sea level. Today, we are delighted to welcome back to the show former and original top quark and current antimatter top quark.
Oh,
Live from San Antonio, Texas, Dr. Tracy Becker. Tracy, welcome back to the show.
Always great to be here.
It's great to see you. Great to have you joining us again.
last time we had Tracy join us was from our European edition.
Yes, live from Geneva.
You've got
last year.
You have generally carefully kept Tracy and I away from each other on the show for good reason, right? If she's the anti-top, top quark.
Tracy and me away from each other. Oh my God.
Oh my gosh.
And
Oh
correction, I did actually make an appearance more recently than that, talking about some Arecibo.
Oh yeah.
We had, yeah, but Jim and Addie weren't on for that. That was just me and you, and we dropped you in through the magic of something called editing.
It was just you and I, Josh.
It was you and I, and that actually is correct because the verb to be takes the nominative case and not the object.
Walkabout the accidental grammatical podcast.
You're right, Y-O-U-R.
Thanks for that, Jim. Our stumpers today are Theodore Geisel. Tracy, were we doing stumpers when you were on the show?
I can't remember if originally, but in my recent appearances, I've experienced the stumpers.
You've had guest stumpers, but I think we started doing stumpers after you left. I think
for good reason.
Yeah. Well, it's impossible to stump you.
That's right.
Right. So, and I wanted to torture Jim, I think, primarily, so that's probably why. So we'll start with torturing Jim. Jim, green eggs or ham?
That is a very difficult one for me personally. I hate ham. But green eggs do not sound very damn good. I don't. What the heck is a green egg?
I used to make green eggs all the time when I was a kid.
What are they? What are you talking about?
I would make scrambled eggs and put a drop of blue food coloring in them, and then they were green eggs.
That's disgusting, right?
No, it doesn't change the flavor.
I know it doesn't change the actual taste, but like it gotta look grotesque, right?
No.
Close your eyes.
It's just like a fun green color. It's just a fun green color.
All right, I'll go with it. I'll go with green eggs because I loathe ham. I am not like some of my friends here a vegan. I do eat meat, but of all of the meats, my least favorite meat is ham. It's disgusting. I won't eat it. So we're gonna go with green friggin' eggs.
Well, the pigs, thank you. Maybe not the chickens, but the speaking of grammar though, green eggs and ham. I guess, was it established that it's green eggs and regular ham and not green eggs and ham?
Where's the parentheses?
How does that logically, where's the parentheses? How does that fit together? To be pondered.
I think the ham is also green.
It's green, eggs and ham?
I think they're both green.
In the
okay.
book,
yeah, if you look at the cover, they're both green.
Okay. The way it's
yolks
written,
are green and the ham is green. The whites are still white.
Not good.
Interesting.
Not good.
Well, Addie, the Grinch or the Cat in the Hat?
It's a hard choice.
They're both they're both annoying as hell.
They are. I think I'm going to go with the Grinch.
Because you hate Christmas?
I felt like a Grinch a lot the last few Christmases. I actually don't hate Christmas. I just feel like I felt like a Grinch a lot the last few Christmases.
Okay.
But the Grinch overcomes his limitations and his heart grows 3 sizes. And I love the Who's. So I'm going to go with the Grinch.
Okay.
I did enjoy reading Cat in the Hat when I was younger.
And you're kind of the Cat in the Hat, sort of a fun party kind of character.
Very mischievous.
That one's too close to home for Addie.
Maybe.
I don't know. I don't like go into people's houses and like make their kids cause a ruckus.
I was gonna say that your Grinch reason, at least, was because Florida is very hot in the winter, and it doesn't necessarily feel like Christmas.
I just never really, I think it's because of both the Florida and just like working right up until Christmas. I just never feel like it's Christmas, but it's mostly the weather. When it's 90 degrees in December, it's hard to get in the mood.
Okay.
Christmas.
Well, Tracy, yours is even more stumpery.
Yep.
Warren Wiggins or Waldo Wu?
So these are pretty obscure characters.
I've never heard of either one of those.
But Waldo
You haven't?
Wu.
Yeah.
Warren Wiggins and Waldo Wu?
I think Waldo Wu. I go.
Why?
Okay. And who are these guys?
I think they're giving each other baths, but Waldo Wu doesn't have to give anyone else a bath, so he just gets to experience the bath, and I think that sounds a lot better.
Yeah, I think Warren Wiggins is scrubbing Waldo Wu with a big bath brush
Somebody
scrubbing
scrubbed
thing.
him.
I think they're washing each other.
No, I think there's
somebody else, right?
There's somebody washing the first guy, and the first guy's washing the Wu guy, and
Waldo Wu. Okay, well, believe it or not,
what is the
It's from the ABC book.
Oh,
our stumpers are Theodore Geisel.
I know, but which one? I never heard of that.
They're from the ABC book. I sometimes still quote the ABC book.
Today
sometimes
we're going to talk.
I say a letter, I'm like, I use the line from the book. I can't think of any right now.
Really?
Yeah.
Wow.
I know. It's impressive.
Today we'll talk about asteroids, which start with an A, and Fomalhaut B, which has a B, and the 30th anniversary of the Hubble Space Telescope, which has a C in there. Telescope. So those are our ABCs for today. But first, this episode of Walkabout the Galaxy is brought to you by the Quark with a fork. It was another sad day all alone in the home, confined by Corona with nowhere to roam. My Netflix had already been thoroughly binged. If I watched any more, I might get unhinged. Amazon Prime and Apple TV and Hulu and YouTube and even Disney were now almost totally lacking in charm. All my books I had read, I saw with alarm. When I thought I had reached the depths of despair with nothing to read and naught on the air, I opened the app on my phone I forgot, called Podcasts, and hunted for what I know not. Past Rogan and Scandal and Planet Money, I really wanted to find something funny, but also a show that would tickle my brain without all that dry, boring lecturing pain. That's when I saw the show about quarks that seemed to be hosted by three friendly dorks. Though nominally it's about physics and space, I found their wry humor a nice change of pace. Whether riffing on rockets or musing on Mars, or speaking of wars, Trek, and all kinds of stars, or dreaming of three-way extraterrestrial sex, the astroquarks will always tell you what's next. Be it gravitational waves or asteroid sampling, or a look at when astronauts next will be trampling the moon dust that is charm's chief fascination, and the rings around Saturn deserve explanation. AstroQuark Strange has a question or two, and sometimes his trivia runs to more than a few, much to the never-ending frustration of top and charm quarks and the Walkabout Nation. So I downloaded Walkabout to help pass the time and was struck by an inspiration to rhyme. I settled in with my AirPods, and while I listened, I wondered what kind of quark I might be christened. So as I downloaded and queued up the next episode, the back catalog is a true mother lode. The AstroQuarks were my company for dinner. I came up with a moniker that is surely a winner. Not strange or charm or top for this quark, no, I will be the quark with a fork.
Beautiful. Wonderful. Excellent job.
I was prepared for that one.
You've got a fork.
Got a fork. I was eating cake.
That is amazing. Excellent job.
So the quark
Thanks,
with
sponsor.
a fork. Yep. I don't have a tagline for that one.
Oh. Yeah.
We can ponder it. Space news, Comet Atlas, which we were hoping but kind of knew was going to be a bust, is now a bust.
Oh, womp womp.
We weren't hoping it would be a bust, but it's literally busted up.
That's like the
Yeah.
last few that we thought were going to be awesome have really bombed out and not been awesome.
Do you think that's just because there's like more hype machine now than there used to be, or
That
like
could be. I don't know. Everybody's waiting for the Haleys.
I think we're seeing them further out.
Yeah.
earlier. And then when they inevitably brighten very dramatically, if they're a first-time comet, we're like, oh my God, if I extrapolate that crazy brightening, this thing's going to be, you know, as bright as Venus. And then because they're a brand new comet, they've never come in before, they just break apart when they start outgassing. So these, I mean, we know, Addie and I know from playing around with dirt balls and low gravity environments that these things are not held together very strongly. And asteroids and comets are both sort of like just sandbanks or snowbanks adrift in space. And it doesn't take much.
It's the title of my memoir, Sandbank Adrift in Space.
It doesn't take much to rip them apart. And so this one has been ripped apart. I guess there's another one called Comet Swan that maybe we'll be able to check it out with binoculars at the end of the month of May if it doesn't rip apart. So
there's
RIP.
RIP Comet Atlas. It's been observed by Hubble, and we'll talk about Hubble in a little bit because it's celebrating its 30th anniversary. And it's kind of cool.
Comet Hubble.
Aw, perfect.
This is for our viewers.
Jim's got a stamp for everything.
There's a stamp with both Halley's Comet and the Hubble Space Telescope on it, as if one passed right by the other. Clearly, that's not how it goes.
Did not happen. Hubble was not in orbit when Halley's Comet flew by last time.
It was not.
But Hubble has been able to observe the breakup, so we'll learn something about comets from this thing, but it's not going to be a sort of fun backyard viewing event. SpaceX, fourth time was the charm.
They did it.
What'd they do?
They pressurized a thing and it didn't blow up.
Yeah, so this is their Starship. The Starship is the upper stage of their Mars colonization sort of whole thing, right? The bottom used to be called the BFR, the Big Falcon Rocket. Pardon my French. But now it's called Super Heavy. And the upper stage is called Starship, where all of the colonists will ride to Mars to live there, I guess. And so they've been sort of building these test vehicles, none of which is yet like a full-sized test vehicle of just this upper stage thing. But so Starship serial number 4 passed the pressure test. It has a single Raptor engine, and next up for it, I guess, is a test flight that's just going to go a few hundred feet.
Little hopper.
Right. And then the next model after that will have 3 Raptor engines, but the full model, when it's all said and done, in principle, will have 6 Raptor engines, and the Super Heavy will have 37 Raptor engines, or have room for up to 37 of those engines. So do you know, Addie, do you know what the thrust of the Raptor is off the top of your head?
Of a single Raptor engine?
Yeah, I've got it here.
Isn't it like
it's comparable to a B4.
Of the Merlin? No. Oh, okay.
Yes, I can't remember what a Merlin is, but the Raptor engine's 440,000 pounds of thrust. Go ahead.
Isn't it cooler to express that it's not the same thing, of course, but in horsepower? Because then you
sure.
can, compare it to like because I was blown away like by what the horsepower of the the space shuttle was on launch or whatever.
I don't even know if I know
somebody that
this.
doesn't know rockets. That's a lot more. I know my car has 100 horsepower or whatever. So the fact that
Tracy, how many horsepower does your car have?
7.
6. Yeah.
7.
No, to the nearest order of magnitude, all cars are 100 probably.
Yeah. Except when I get my Bugatti Veyron that has 1,000, that's going to be awesome.
Oh.
But
so do you remember how many horsepower the space shuttle had?
I don't know. It was on the order of a few million or 10 million or something. I mean, it was stupid, something.
Okay.
Big. Well, I don't know what this big one is. How many people are going to fit on this Mars thing once it's full size?
That was my question. Like, what kind of mass?
37 million horsepower on the space shuttle.
37 million. Yeah.
I think they were talking at one point. They were talking about dozens of people.
Yeah.
on a trip to Mars. So, but I don't have the horsepower numbers, but I can compare this to the Saturn V rockets, the moon rockets, which remain to this day the most powerful rockets, highest horsepower or whatever that have ever flown, that were about 7.5 million pounds of thrust. They had 5 of these engines that remain to this day the most powerful engines ever to fly. Each one of the Saturn V engines was equivalent to about 4 of these SpaceX Raptor engines in terms of thrust. And so if this, this super heavy 37 Raptors would be close to twice the thrust of the Saturn V moon rocket at launch for the first stage. Crazy. Speaking of launches, we're still counting down. We're less than a month away now from the Crew Dragon.
Crew Dragon.
And that's taking two astronauts for this one.
2 astronauts, yes.
Up to the International Space Station. And NASA administrator had something to say about it, right, Addie?
He did. He said, don't come watch the launch. Which is super bummer. I mean, I think a lot of I'm sure Floridians will, but they're telling people, especially people who live there, right? But they're telling people who are from other places, I guess, to not drive out to come. They have hundreds of people lining the roads and all. They have, for the last Falcon Heavy launch, right? It was crazy. They had to shut down traffic around the center and all this other stuff. And so for this one, they would have expected to have insane crowds and I'm sure they would have sold out all sorts of viewing areas and all of that, but I think they're going to try to.
You would need an insane crown posse to manage that.
Oh man, ICP canceled. Isn't it them who canceled their annual gathering?
Yeah.
The Juggalo thing or whatever was canceled.
It's a shame.
Yeah, the high profile launches can get crazy crowds down here on the Space Coast. When I was a kid, I went to the first space shuttle launch. I was in high school, and I drove down with a friend of mine 24 hours in advance, and we just camped out on the side of the road and slept in the car to see the launch the next day. And it was scrubbed for 48 hours. And we drove back up, came down, and did it again. But there were insane crowds and no posse.
I thought you were going to say you drove down to see the first Kitty Hawk flight when you were a kid.
Oh, good one, Chim.
Oh.
Boy.
Zing.
You're old. That's what I'm saying.
Weak.
Wow.
Yeah.
I was gonna say, so they announced the date for that a little while back, and they haven't said anything more about it. So they're still shooting for end of May, I think. We'll see.
There was a report from a committee that sort of meets every quarter to monitor human space flight operations in the U.S. that was created after the original Apollo 1 disaster, this committee back in the 60s. And they met recently and said it's still okay to proceed with the planned schedule, although SpaceX does have some things that they need to clear before the flight in terms of some final parachute tests. They're doing a drop test of the Crew Dragon capsule before the launch. So all those things have to go. Obviously, every time with a launch, we've seen these things get delayed literally after they have lit the fire underneath the engine to start them going. And then they're like, oh, problem, shut it down.
Yeah.
So it doesn't go till it goes.
Well, all you Floridians at least can still see it from your homes, which is nice.
It is great. Yeah.
I don't even know if Kennedy will be open for regular employees by then either. So even Kennedy employees might not be able to see it like they usually could. Yeah, we'll be able to just walk outside and see it.
That was fun.
Let's talk about Hubble Space. Yeah, go ahead.
Oh, there was one more little space newsy thing today, which is that there are 2 sunspots on the sun.
Oh.
And it's kind of cool because they are from the previous solar cycle and the new solar cycle. So we're sort of in the transition period right now. So one of the sunspots is from the old solar cycle 24, and one is from 25.
Okay.
And they can tell which one's which because the polarity, which way the polarity is facing.
Oh.
Because the solar cycle has to do with when it flips.
Awesome.
Oh, that is cool.
Yeah.
Yeah. Okay.
So we're
That's
actually
cool.
starting we knew we were supposed to be starting a new solar cycle, so they're starting to see that flip. But there's been a lot of, we've been in a minimum, so there's been a very few sunspots so far this year.
I feel like
So
we
we're
should
now
have
pulling.
fireworks, like a new year, but like a new solar cycle. Celebrate it.
Yeah.
So we're
Well, there
pulling
probably
out.
won't be any fireworks from these. They're not having any big coronal mass ejections or anything yet, so.
So we're pulling out of the current solar minimum, which means the sun's getting more active. And this happens on an 11-year cycle is the period of it. And there's a polarity switch, so it takes 2 11-year cycles to do a full sort of cycle. But they don't exactly repeat. So lately, the maximum have not been as high as in previous cycles. So it's interesting to see what this one does. One of the things that happens, speaking of rockets and things like that, is during these cycles, as the sun gets more active, it deposits more energy in the Earth's upper atmosphere, which causes it to expand a little bit, which increases drag on the space station and other things in what's called low Earth orbit. And segue alert, one of the things that's in low Earth orbit is the Hubble Space Telescope.
Ah,
Excellent.
yes.
Yeah. And I think of the 4 of us, Tracy Becker is the only person who's been the principal investigator of a Hubble Space Telescope observation program, and maybe several.
Yeah. And Josh is a co-I on one of my programs.
Woohoo!
Yeah. Yeah, so I get to use the Hubble Space Telescope, which is awesome. I have very different projects with it, although it's all in the ultraviolet. But looking at asteroids, looking at Jupiter's moon Europa, and looking at Saturn's rings.
So how does one use the Hubble Space Telescope? You
go up to it.
You ride up there in a rocket and you put your eye on the back and.
I wish. No, I wrote a science proposal, which are about 3 pages of science and 5 pages of, are you sure this is actually a feasible program? And then a bunch of other scientists judge it, and they decided that my science idea was worth trying. And so then they point everything. I help kind of guide what I need for the observations, but generally it's all kind of done by the team at the Space Science Telescope Institute.
So they steer, they program in the pointing and when it's going to be taking its observations, and then at some point you get an email that says, here's your data.
Yeah, it says, log in, collect your data. You get it for about 6 months, and then after that it's free game for everybody else.
After that, they email the world and say, everybody in the world, here's Tracy Becker's data.
It's just there. The people looking for it can find it.
So all of our listeners could find all your data now if they wanted to.
And you can see like a very basic plot of that data right away if you go to the website.
Okay.
Do you planetary scientists get bummed because when people talk about Hubble, they almost always think of these deep space images from Hubble, like planetary nebulae and galaxies and all these fun things. But you guys are using it for much more closer to home objects, and you rarely see, or not as often see, images of those things. Are you bummed?
No, because a lot of the cool press that comes out are still from Hubble, from solar system objects. So like the discovery of potential plumes coming out of Europa were all done by Hubble Space Telescope observations. You do get really good resolution, so you can like kind of look at some of these planets and moons that makes a pretty picture. So I think Hubble was the one that found the targets after Pluto with New Horizons. So you can do a lot of cool stuff with Hubble in the solar system that still maybe doesn't make as pretty of a picture, but still really awesome science.
Also, the thing is that for planetary science, we actually just go to the planets.
Yeah.
So
yeah,
I mean, I can't begrudge the astrophysicists their flagship telescopes like Hubble and James Webb Telescope, because they can't go to a galaxy or go to another star to study these things. So those are their primary flagship spacecraft to collect that data, whereas we're sending rovers to Mars, we're sending orbiters to Mercury and to Jupiter and Saturn, and landing on moons and collecting samples from asteroids. So, and we get amazing, spectacular pictures from those things that, so that's great. There's plenty of great science to go around, and each instrument's got its own thing. So
we should, did we mention why we're talking about Hubble? Because it's
go for it.
30th anniversary of the launch of Hubble, right? 1990. That seems crazy to me. That's 30 years. That's the good portion of my adult life, or all of my adult life, I suppose.
Yeah.
That's pretty crazy.
Yeah, that coincides basically with my professional career, 1990. But I've never, aside from working with Tracy on this one Hubble project of hers, I haven't actually done anything with Hubble myself.
Yeah.
Because that 1990 also coincided with when I started working on the Cassini mission. Have I mentioned I worked on the Cassini mission with Saturn?
I don't think you mentioned on that.
Well, one of the
Hubble's
about Hubble that you can't get with a lot of other telescopes, and what I focus on is ultraviolet, since I worked with Josh originally, so doing ultraviolet observations with Cassini. But so if we want to look at anything else other than using a spacecraft, you really need a space-based telescope, because our atmosphere doesn't let in much ultraviolet light, fortunately for our skin.
Thank you.
But unfortunately for our observations. So that's mostly why I use Hubble, is because it's the only telescope that can actually do the observations at the portion of the light spectrum that I'm interested in.
What's the sort of expected lifetime now for Hubble?
Oh,
how long?
I just read an interview with the director of the Space Telescope Science Institute. And so Hubble, of course, has been serviced 5 times. It was designed to be so you could replace components of it. And there were 5 space shuttle missions that went to Hubble, and they fortunately were able to fix the problem with the primary mirror that was a perfectly wrong mirror.
It needed repairs sooner than
they
expected.
ground it exquisitely finely to the wrong shape so that it wasn't focusing properly originally. So they were able to correct that, put new instruments in, replace the solar panels, all sorts of upgrades. But there are some original hardware on there. So the director of the Space Telescope Science Institute expects 5 more years of operation for Hubble. But he says, of course, there are some original components that could fail tomorrow. At the same time, the components that have been put in have sort of gone through their sort of burn-in phase. Like if there's something intrinsically wrong, they would have failed already.
Yeah.
So maybe it'll go for another 10 years. So optimistically, maybe 10 years. Realistically, maybe 5. And part of it I don't know how susceptible it is to what we were just talking about with atmospheric drag. I know it's not going to be
It's reasonably susceptible. I was reading about how they're going to end it when they end it, right? I mean, it's going to likely burn up in the Earth's atmosphere, but it's got big, heavy parts that might make it through the burn if it's not a controlled burn through the atmosphere. And so they originally had planned to grab it with another shuttle mission, but since that is shut down, they have to do that. But I guess it's isn't the most likely failure here the gyroscopes on that thing? Like the moving parts are, of course, in these things the most likely to fail, and these things have these spinning wheels in them to keep them pointed where they're supposed to be pointed and move them where they're supposed to move the pointing around. And since those things are continuously spinning, they can break down, and many of them have broken down. I think we're down to 3, right? Operational gyroscopes on this thing, and that's really what you need to do the pointing properly. I think you can still do some things with 2 or 1 spinning wheel, but it gets a little bit difficult to point how you want to point, and you can't do all the things you want to do.
That was the downfall of the Kepler Space Telescope mission. That's the mode of its failure, is that it lost, so it no longer had 3 functioning gyroscopes so that it could maintain the perfectly precise pointing that it needed. And Cassini had 1 spare. Did I mention I worked on the Cassini mission?
No, I don't think so.
It had 1 spare gyroscope, and they went to the spare gyroscope very, very early in the mission. One of them was showing some weird problems.
Oh, that's scary.
And those things are spinning. They're big, massive things, like you said, Jim, with big flywheels that are spinning at very high rates of spin.
Gyroscopes are so crazy. Just thinking about like how you have to spin up spacecraft and then like despin them, right? And it's so cool.
Let me tell you what the trivia is, but then since we're talking about Hubble and ultraviolet, we'll talk then next about what Tracy's been looking or planning to look at, you mentioned Europa and plumes, so we'll talk about the Clipper and then this asteroid thing. So here in our sponsor insists, we have a sponsor for every episode, and in return for sponsoring the episode, they have certain, sometimes they have certain requests or asks of us. So the trivia question was a request from the sponsor. The trivia is doctoral.
Okay.
The following characters, and I'm going to give you 8, are either Dr. Seuss characters or Dr. Dolittle characters.
All right.
Okay.
Have we done Dr. Seuss characters before? I feel like we've done something like that.
I don't think so.
Okay.
I don't think so. So I'm going to read you 8 characters.
My life.
Each is either Dr. Seuss character or a Dr. Dolittle character. And we'll come back to these after we talk about Europa Clipper and dangerous asteroids. And you'll get your guesses. There's no guarantee about how many of each category there are. Okay.
Okay.
Except that there is at least one in each
All right.
category. Here are your characters that are either from Dr. Seuss or Dr. Dolittle. Yertle the Turtle, Whale Number 1, Great Glass Sea Snail, Push Me Pull You, Goo Goose, Funa Laguna Baboona, Duck Dog, and Gub Gub.
All right.
Got them? All right.
Got them.
Ready.
There should be some easy ones in there and maybe some not as easy ones, but we'll see. If they all turn out to be too easy or too hard, we'll blame it on the Quark with a fork.
Perfect.
Okay. So Tracy mentioned some of the things you're interested in. You can only see with ultraviolet light, and you said, oh, by the way, and Hubble saw these plumes from Europa, which that discovery kind of indirectly got you your job.
Yeah, but I didn't do that discovery, to be clear.
No, I know.
True.
You didn't make that observation. Somebody else made that discovery. And as a result of that discovery, they added onto the payload of the Europa Clipper mission, which they had not previously planned to have on there, an ultraviolet instrument. And that ultraviolet instrument then said, who's the best faculty member who trains students about ultraviolet measurements? Josh Caldwell. And what student does he have coming out? Doesn't matter, we'll just take her because Josh Caldwell trained her. So I think that's pretty much.
That was my acceptance letter for my current job. I'm pretty sure is what that said in there.
That's pretty much how it went down, I think.
Has she worked on Cassini? And
yeah, so I also worked on Cassini.
yeah.
I hadn't heard that too. But yeah, so I had good UV observational experience working at UCF with these other quarks. And then, yeah, so the Europa Clipper has several instruments on it, one of which is the ultraviolet imaging spectrograph, which is the one that I work directly on, but I also work directly for the entire mission as the composition working group co-chair. So I do a lot with all the instruments now.
Yeah, but what do you want to see when you get there?
Oh, we want to see plumes. So we want to do a lot of stuff. Basically, Europa, if you don't know, is a moon of Jupiter that has a liquid water ocean underneath its ice. And we want to know kind of everything about the interior, the exterior, and the surrounding environment, and to assess whether or not that moon could be habitable. So whether life could potentially have existed, currently exists, or could exist in the future.
Big sea serpents swimming around in that subglacier ocean.
Yeah, that would be great.
Or
We
bacteria.
always said
maybe.
we always said it was like the saw. What are the fish that have the like saws on their faces?
Oh,
There's a sawfish.
Sawfish. That's what I was gonna say, but it sounded so wrong. I said it was sawfish underneath Europa that made the little lines all on the surface.
Nice. I was gonna say ones that have like little lights or something, so they can see in the dark. Like
How
that's true.
How thick is the ice shell covering that ocean on Europa, Tracy?
So that's one of the questions we're trying to figure out. We have an instrument that's a radar instrument that will be able to kind of ping down to see when you kind of transition from an ice to maybe a liquid, but it might be too deep for that. So we'll have to do some indirect observations to try to figure that out. But basically, like, is it a couple kilometers? That's kind of where we're thinking. And so it could be pretty thick. But we do see evidence of liquid that has frozen over on the surface. So maybe maybe giant sections of the ice can just suddenly turn over. And so we can see kind of the belly side of a big giant iceberg type thing. We see that kind of happen on Earth sometimes randomly. So we're maybe excited to see if that's what's going on Europa. The surface has all kinds of different texture and different kind of just different ridges and different regions that maybe even look like the ice is separated and liquid is poured out and refrozen. So there's a bunch of possibilities that we might be able to see what's under the ice without ever having to necessarily go under the ice. Although one day that would be great too.
And these plumes with the ultraviolet instrument is special for observing these plumes in some way?
Yeah, so the way that the plumes were first detected using Hubble was by actually looking at kind of the aurora, so the northern borealis type thing that happens at Europa that also happens on Jupiter, happens on Earth. And basically what they saw was the emission of light from hydrogen and oxygen at the exact right ratio to say this was once H2O. So the UV is very, very susceptible to those two kind of fingerprints of hydrogen and oxygen emission. So it was very, very clear in the data that those two things were emitting at those exact right kind of ratios and lasted for several orbits of Hubble. So for a few hours basically. And so we think that was the first indication of a plume. It's not necessarily 100%. We didn't take an image of an actual eruption yet. That's what we can do once we get there with Europa Clipper if they're currently active while we're there. The second way we detected the Hubble plumes, the plumes using Hubble, was looking at Europa go in front of Jupiter, and off the limb of it, we saw kind of a little blip that looked like there was some structure off of the edge of Europa, and that backlit signal from Jupiter being absorbed by that blip told us, hey, maybe there's some kind of eruption happening right now on Europa too. So there's been two detections that way, and then a reanalysis of old Galileo data, which was a spacecraft that orbited Jupiter for a while in the 90s. Also there was sort of always this weird flyby of Europa that we didn't fully understand, and with newer models, they've reinterpreted that to mean that we probably saw a plume there too.
I sort of feel like there's kind of like 100 hints that this is happening, but we're still looking for this, not the smoking gun, but the steaming gun.
Yeah.
Or something, the actual, like, here's the picture that everybody looks at and goes, oh my gosh, there's stuff venting out of Europa. So that's exciting. When does Europa Clip?
We have that for Enceladus. We have that for Enceladus from Cassini. Right. And so that's sort of the image
gold standard
convincing thing once we get there. But with the UV instrument, we'll be able to sort of look kind of throughout and try to see if we see those same emission features when we're far away. And then once we get closer, a lot of the instruments would have the capability of imaging the actual plume or seeing it indirectly in other ways. But the main thing too that's cool about Clipper is if we do see it, hopefully we can have the spacecraft fly through it or very close to it, and then actually have instruments that can collect the physical dust or the actual gas and tell us way more about what's in that plume once we get through it.
Yeah, the SUDA instrument, right, is on Clipper?
SUDA and mass specs. So SUDA will collect the actual dust, and then mass specs can do the actual gas. So Sniffer.
Yeah, SUDA's the dust instrument.
Yeah.
Nice.
But it can do composition stuff too. So it's cool. It'll like collect if the dust comes in, and you can sort of tell where it's coming from and how big it is. But then also if it hits a surface, it sort of breaks apart, and you can look at the sort of plume and its own plume and what the composition is.
Is that not dangerous to the spacecraft if you're flying through a plume of stuff? No.
They're so tiny.
Yeah, I mean, they're pretty careful about it when they do those. They do a lot of observations before they'll do the fly through.
Yeah, I think it'll take a while once we actually detect an active plume and then some analysis of that plume before they'll let us fly a precious spacecraft through it.
Yeah, but the particles are probably going to be too small to really be harmful.
Yeah, and they can do it at a pretty high altitude where they've basically been escaped from the thing already, so they'll have very little relative velocity with respect to the spacecraft. And
cool. So when does, just to wrap up on Clipper, when does it launch and when will it get there?
Early 2020s, and so should get there late 2020s.
We're already, this is the early 2020s, Tracy.
Yep. Well, they're still deciding on which vehicle we're going to launch on, so that has some implication for when we actually launch. And then, but sometime in the early 2020s is still the plan. And then we would get there in the mid to late 2020s, depending on
That's
the
pretty
launch.
vague. But you're saying arrival before 2030
That's the
in
current
Jupiter.
plan. Yep. And again, depends on
Okay.
spacecraft. So if we fly on NASA's SLS, that'll get us there very quickly, but may take longer to actually be ready for us to launch on. Whereas if we fly on something like a different, if there were different spacecraft ready for us to fly on, or a different launch vehicle, we might have to do things like, use gravity assist
Or gravity assist
from other planets before we could get there. So it's a little bit still up in the air, but the goal is 2024, I think, right now of launch, and then we get there like late 2020s.
I'm going to call that mid 2020s, not early 2020s. Just my editorial opinion.
Speaking of launch vehicles, really quick, I'm going to throw back to what we were talking about. I forgot to say that with the last Starlink mission, the last Falcon 9 launch and the Starlink mission, the Falcon 9 became the most flown active rocket in the U.S.
Yeah.
So like,
what's the most flown rocket period though?
That's I need to look. I was just thinking that because I need to look it up. But it's the most one that's like, because it's operational. Because before that it was the Atlas V had flown the most. But Falcon 9 has 84 flights now, and so it has the most.
And counting, because there's 2 more this month. Happening. Yeah. And the Atlas V is still flying, but not at quite the same tempo as the.
Maybe I'll make a trivia question about number of flights per rocket.
Also, throwing back earlier when we talked about Comet Atlas having disintegrated, something else has gone missing, but around a different star.
Dude, this is the thing that blew my mind this week. I got very upset about this.
Oh no.
Yeah, well, so
you are. To be fair, Jim, you are easily upset.
I am very easily upsettable. Yeah. I get upset like that. But this is upsetting because we've talked about exoplanets lots on the podcast here, and we've talked about how detecting exoplanets is mostly secondhand detection. I mean, not secondhand, but using gravity and so forth, seeing the wobble of the parent star or seeing the dimming of the parent star. But actually seeing the exoplanet itself is a very rare, difficult thing, because you have to have a very big, bright exoplanet that's very far away from its star in order to be able to actually see it, in the shine of the star. And so we've only seen a handful, I don't know, half a dozen or something like that, exoplanets actually seen, in images. And one of the first 2 that we imaged was called Fomalhaut B, right? So there's a star Fomalhaut, which is a big bright star in the southern hemisphere. It's like 25 light years or something away. So it's a nearby star, and Fomalhaut B is a planet around that, which we had seen using Hubble Space Telescope, I believe, in 2004 and then again in 2006. And so we have these images where you can, see those 2 images piled on top of one another, and we can work out the orbit of this thing. And I've shown this in my, astronomy 101 classes and so forth as an example of an exoplanet that we can see. It turns out
it's one of the ones that's used a lot because the image looks like the Eye of Sauron or something. So you see that image all the time.
Right. Well, the Fomalhaut system is a very interesting one. The star is surrounded by this huge torus of dust. Kind of like our Kuiper belt, but dustier and much larger, much farther away from the star. And you can see that in the images, and so all the light scattered off of that stuff, and so it does look like the Eye of Sauron.
And actually, can I ask a question, Jim? Are we seeing that dust ring from light that's scattered off the dust, or from the thermal emission from the dust because it's heated up by the star and is glowing
largely
infrared?
From the scatter. This is not infrared. This is
visible light.
Visible light.
Okay.
But one of the other things you see in that are, in addition to the background stars and stuff, is Fomalhaut B, that planet moving around in a nice orbit around the star. But in the last little while, it's disappeared over the past year. It's just not there anymore. And this freaked me out because apparently it wasn't a planet all along.
What?
It wasn't a planet. Apparently, we don't know exactly what the story is, but apparently the most likely scenario is it was the debris from a cometary breakup or collision of comets or something like that temporarily produces this, dense pile of debris that is very reflective. So you can see it in visible light. We never did see it very well in infrared light, and that makes sense.
I thought that the disk view was infrared though.
It's
So
conceivable.
like Eye of Sauron
I don't know.
is infrared, I think.
Is it?
And I think it was taken with Hubble to tie all of our stories together.
That's what I said.
Well, if it was taken with Hubble, it wasn't infrared.
Yeah, the
I
Hubble's not an
think it
infrared
is
telescope.
though. I don't know. Okay.
Well, Hubble doesn't have any infrared detectors.
It's visible.
It has some near
Yeah,
infrared.
it's got near infrared stuff.
Oh, okay.
But the kind of
Okay.
infrared you'd see from a dust out there would be much different wavelength, right? I mean, it's because it's cold. It's a very cold.
If it
thing.
was thermal,
Right.
If it was
Right.
thermal infrared, it would be at much longer wavelengths
Right.
than Hubble could see. Be like you'd be in James Webb territory.
Right. Well, in the end, it's gone in all wavelengths now because
no.
if this is a pile of debris,
Can we
right,
get our money back?
slowly dissipate, and so it's gone. I think this is a cool kind of parable, or the moral to this story is a lot of people think, you got to see to believe, but here the one we saw was the one that's not real, right? The ones that you see with that you see in quotation marks with gravitational wobble, those are the ones you can really believe in, right? But the ones you see, just because you see it doesn't mean it's actually there, right?
Well, yeah. So we run into similar things. Tracy knows with planetary rings, and when you're looking at stuff, you're seeing the surface area.
Right.
And when you're seeing that gravitational wobble, you're seeing the mass.
The mass, right.
How much stuff there is. But surface area is very illusory. I mean, take a look at any movie set. They have facades and paintings that look like an entire city, but no, it's just this sheet of canvas that is dressed up to look like it. And so similarly, you can take a relatively small thing like a moon the size of Saturn's moon Mimas, which you can't see with a small backyard telescope, but if you pulverize it into a bunch of golf balls and scatter them around Saturn, it makes these gigantic ring system. It's the same amount of stuff, but now covering much more surface area, and it's super, super obvious. So it sounds like that's what you're saying happened with Fomalhaut B, is like there was a lot of surface area, but not a lot of stuff.
Right.
And so that probably meant it was something that had been broken up.
Right. Which is kind of exciting in its own right, because these events where something breaks up like that are not going to be super common. We happen to catch it there. So that's
right.
coincidental and pretty cool. So you get to see that kind of event. But it's certainly disappointing that I've been telling my students for years and years that there's a planet and it's not it.
Yeah. Well, a good parable, as you say. Is there any chance?
There were some parts of those observations that were always a little challenging, right? Like how far out the planet was, and like you said, the fact that we could see it in visible, but not as much in infrared.
Right. It was always a mysterious kind of a situation, and now it's kind of maybe less mysterious, but yeah, it's different.
So Tracy, is there any chance that the Earth is going to be broken up by a collision with 1998?
Oh yeah.
Whatever.
No, and by the time I think it airs, it will have already passed by the Earth perfectly 16 times.
So
are you just saying that, or is that BS? Because I just watched the movie Melancholia and I'm freaking out.
I haven't seen that one.
Oh.
But this asteroid is passing 16 times further away than the distance between the Earth and the Moon.
That's a comfortably safe margin.
Very far.
Right, but you were involved in were you involved in the imaging of this with Arecibo Observatory?
No,
or just
not directly.
So this is, go ahead.
I was going to say, yeah, the team at Arecibo, the team of scientists, were just taking radar images of that asteroid. It was a particularly exciting asteroid just because even though it's still 16 times farther away than the Moon, it's relatively big and relatively bright, and so there was a big campaign, a lot of people observing it with different telescopes, and Arecibo being among them. And Arecibo can do the radar imaging, which is when they send that signal of radio waves to the asteroid and see what happens when it bounces back. And so they can actually kind of create an image from that radar observation and get an estimate of the shape, of the size, and also a good estimate, a really, really accurate estimate of exactly where it is and what its current velocity is, so they can kind of project that out to see where it's going to be in the future.
So it's definitely a safe asteroid for us for the foreseeable future. Did it have a moon by any chance?
It did not have a moon.
Oh, too bad. But it did have a surgical mask, is what they're saying in the press releases.
Yeah. So the
For some
the
reason.
lead.
That was a bit of a stretch for relevance, but that's fine.
So the head of the planetary group there, Dr. Ann Bjerke, she took a nice picture of herself wearing her mask because obviously with the coronavirus epidemic happening right now, people had to be careful, and so there's fewer scientists working at the observatory at any one time. So she was wearing her mask, and the way that the radar image comes back at you, you kind of get like a crescent moon shape almost. But in this one, there was also a fun, an interesting ridge. So it is science-y. There's an actual, probably some sort of topography, some sort of ridge happening on the equatorial part of the asteroid, and they kind of flipped it, and it looked like a little bit like a mask. And they tweeted that out, and that got people excited. So
it's an iapetus.
All right,
Got a ridge.
let's get your collective wisdom on the fanciful characters from Dr. Seuss and Dr. Dolittle.
All right.
I'm going to go through the list provided by the Quark with a Fork here. I'm just going to go through. You say Seuss or Dolittle. Yertle the turtle.
Seuss.
You're correct. Did you know him?
yes.
Okay, I didn't know Yertle the turtle. Whale
What?
number 1.
Doolittle.
Doolittle.
Little.
That is also Dr. Seuss.
Which is that from?
Dr. Seuss. I don't know.
Disappointed.
I didn't write these. The Quark with a Fork wrote it. The Great Glass Sea Snail.
Doolittle.
Doolittle.
That is Doolittle. The Push Me Pull You.
Seuss.
Dr. Seuss.
Seuss.
Are you kidding me? That was supposed to be the easy Dr. Dolittle one. The
I
Push
was
Me
gonna
Pull
say, I
You.
think that's it's Doolittle. Yeah.
That's the only like Dr. Dolittle one I know off the top of my head. The Push Me
It's been a
Pull
while.
You is
I haven't watched
half.
it.
I've never
It's
seen
half
or heard or
unicorn.
read Doolittle.
It's a two-headed quadruped with a head at each end.
From which Doolittle?
I think the original one
How's it
and
poop?
all of the others.
Oh, okay.
The Push Me Pull You, it's half unicorn, and I don't remember what the other half is, but some sort of herbivore. And one speaks while the other's eating, so he can, do fine that way. The Goo Goose.
Doolittle.
Doolittle.
Seuss.
It is Dr. Seuss.
Nice.
Funa Laguna Babuna.
Doolittle.
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 Maybe.
I'm nailing you guys. That's Dr. Seuss again.
That was kind of rhymey. I guess it should have been Dr. Seuss.
Yeah. You guys have to go back and study up on your Seuss and Doolittle. Last two, the Duck Dog.
Doolittle.
Doolittle.
Seuss.
It is Seuss. And finally, Gub Gub.
Doolittle.
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 That is Doolittle. Anyway, hopefully you're either glad that's over or inspired to go check out some of those.
Whales 1 and 2 are from If I Ran the Circus.
Okay. I know Thing 1 and
Whales in the
2
circus? It's ridiculous.
Sure.
If you ran the circus, yes.
You do whatever you want.
Where are you going to keep them in?
No, if I ran the circus, there'd be no animals. Let them all go.
Aw.
Oh, very
Really
nice.
interesting circus.
While it may have felt like an elementary school reading lesson, this has been another episode of Walkabout the Galaxy. If you liked this episode of Walkabout the Galaxy, give us 5 stars on Apple Podcasts. Also, give us 5 stars on Apple Podcasts, even if you didn't like it, because you have to admit, while you may think you didn't like it, you did stick around to the very end to hear this. Just saying. Thanks so much to Tracy Becker for joining us, Antimatter Top Quark. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy, where you can see Jim Cooney's amazing Hubble Space Telescope stamps live in color. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Production assistance is provided by Diego Rodriguez. Jillian Gloria is Director of Marketing. Thanks to our listeners in Hollywood and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the AstroQuarks signing off until the next episode of Walkabout the Galaxy.